and we're on. All right, so what we've done already is we've looked at oh gosh, what's going on there? What on earth? Sorry, everyone. Yesterday it was the internet. Today it's the pen. It's gone crazy. Okay, so yesterday we looked at alkanes, or a couple of days ago anyway, and they undergo two types of reaction. They undergo combustion, okay, and they undergo what's called substitution. Okay, believe it or not, even though you wouldn't know this, both of these are free radical substitution reactions. Or they're actually, I should more correctly, I should say they're both free radical type reactions, because alkanes undergo free radicals. And the one we did the other day was the simple case of methane reacting with chlorine, and you get chloromethane, CH3Cl, and HCl. And this guy here, whoopsie daisy, this guy here is known as chloromethane. All right, and more importantly, for today anyway, it's known as a halogeno alkane. Okay, and that just means an alkane with a halogen on. Okay, so if I were to react with more chlorine, this guy here, my halogenoalkane, this guy would react with more chlorine, and further substitution would occur. Okay, so if I do it once, I get chloromethane. If I do it twice, I get dichloromethane. Okay, and if I did it again, I'd get, whoops, that's not right at all. I would get trichloromethane. And if I did it again, I'd get tetrachloromethane. Now, interestingly, this last one is called tetra for 4, chloromethane. And this one is called trichloromethane. Trichloromethane. And this third one here, the trichloromethane, is often known as chloroform. Chloroform. And if you've ever seen these movies where they try and put a hanky over someone's face and try and make them fall asleep, they say they use chloroform, and that's what they use, this guy here. And this one, also, chloroform is also, interestingly, it's dry cleaning fluid. So if you go to the dry cleaners and you smell that funny smell in the dry cleaners, it's chloroform. All right. It doesn't make you sleepy though, particularly, does it? I must admit, I wouldn't want to work in a place like that and breathing that in all day. But that's chloroform. Okay, CCl3. Are we all good? Everyone's happy so far? Excellent. Well done, Tamani. All right, Janet, you good? Well, Tata's just left us for some reason. Janet, can you hear me? Just put a thumbs up. No. Maybe Janet's gone off somewhere. All right, so that's a recap of what we did the other day. And today we're going to look at what are we looking at? I can't remember. Alkanes. Alkenes. I keep saying alkanes. Okay, so today we're looking at alkenes. Okay, now obviously the most important thing about an alkene is the double bond, isn't it? So there is the first alkene. Okay, and this one is ethene. And it has a formula C2H4. The next one is going to be 3 long. 1, 2, 3. And the double bond can go either there. Well, right, there we go. We have to remember each carbon can only have 4 bonds going around it. So this one is known as propene, isn't it? And propene has a formula C3H6. Okay. Now, obviously, I'm sure you know this. But these two things, all right, it has to be said just in case there's anyone confused. These two things are the same. Okay, all I've done is I've rotated it, haven't I? On the x-plane, not on the x-plane, on the x-axis. Okay, I've rotated it around the Y plane on the x-axis, as it were. Okay, so I've just flipped them around. They're exactly the same. I hope we know that. All right, ethane and propene. Sorry, ethene and propane. Obviously, we should all know this is a stupid question, but believe it or not, I've seen it asked, why is there no methane? Well, there can't be a methane because to have a methane, you'd have to have one carbon atom, and to have one carbon atom, you couldn't have a double bond between carbon atoms. So that's why there's no methane. So you have ethene, propene. They're the only structures for those two. Okay. The reason I'm doing this, I want you to get familiar with formula. All right. After that is butene. Now, 1, 2, 3, 4. Now, interestingly, butene does have isomers. These first two, ethene and propane, they've only got one structure. Only one structure possible for these guys. And so therefore they have no isomers. All right, there's no isomers for those two. But in bute, we do get isomers. Okay, the double bond can be here, or the double bond can be here. Okay, so, Janet, you all right now? You left us for a minute there. Are you good? Is internet a problem today? Quite a few of you are dropping out and dropping back in. Is internet messing you around? If it is, put a down thumb. A down thumb. If it's good, if your internet's good, put an up thumb. There's no thumbs at all. All right, it's fine now. Yeah, you know what? Remember mine was bad yesterday. I phoned up. Well, I didn't phone up. I emailed BTC, and yeah, my internet was bad yesterday, Janet. I emailed BTC, and like half an hour after that, for some reason, it started working. It's like they read my email and they fixed something. But you know what they do? I've reported a fault with them. You know what they're going to do? They're going to come round. They're very good at coming round. They come round quite often, quite quickly. But they're going to come round, and when they come round, all they're going to do is they're going to change the router box. You know what I mean? When the problem isn't the router box, the problem is the inflow of the information. It's nothing to do with the router, but they'll change that and they'll leave and they'll say they fixed it. And they know they haven't fixed it. That is life, isn't it? Anyway, so these two are isomers of butene. So these two are isomers. And both of these guys are C4H8. All right. And we've talked about this before. What are these guys called? Right. The one on the left is, remember, I can't remember who got this right. I think it was Damani. But this one is called butanene. And this one is called butene. Okay, now, why do we call them that? Well, we say where the double bond starts from. So the double bond goes between 1 and 2, so we call that one butanene. And this one, we say the double bond starts between 2 and 3, so that's called butene. Can anyone see, are there any other isomers of butene? Yes or no? Any other isomers? Timani says no. Janet says no. Everyone says no. And the answer is yes, there. Oh, Tata says no. Yes, there is. Okay. You're not thinking like a chemist. One. Oh, different color. Come. Give me the yellow. One. Oh, that's ugly as hell, isn't it? Let's get rid of that. 1, 2, 3, 4. Double bond there. Yes. That's an isomer, isn't it? Okay, and there we have that. There you go. Anyone want to give me the name of this guy? The one that you didn't see? Anyone? Name of that? Anyone? No one? IDK, don't forget, or a thumbs down if you don't know. I don't want to embarrass anyone, so I don't want to hang around. Methyl propionine, that's perfect. Well done. That's exactly what it is. All right, this is methyl propene. Interestingly, you don't need the number prop 1 there. It's good that you're using it, all right, but you actually don't need it. Okay. Now, if I move the double bond to here or here, believe it or not, it's the same thing. Okay, you can move the double bond around, but it's still methyl propane there. So there you go. So you're right. There's only 3 isomers of butene. There they are. All right, now we're going to go back up to the top, and we're going to give these. Obviously, we've got molecular formulas, haven't we? Molecular formulas are pretty useless, aren't they, if you remember? So now I'm going to give some structured formulas. The formulas I've given so far are known as displayed. So all of these guys so far are called displayed formula. These are displayed. And if you remember, displayed shows all bonds. Shows all bonds. By the way, if you're interested, you 4 or you 3, oh, who's dropped out? Tata, Janet. Oh, yeah, the other 2. Helene doesn't come to many. I think she's in South Africa. But if you're interested, I have a lesson tomorrow night at 7, okay, on electrochemistry. All right, guys? Now it's to the Maripula students. So if you're interested, write to me if you don't want to, but you're more than welcome to come. All right, they're a lovely bunch. They really are. So if you want to come tomorrow, we'll be having a lesson at 7 on electrochemistry, okay, with some Maripula students. Okay, so that's if you're interested. Okay, and as I said, they're lovely. They really are nice. I'll post the link to it if you want to come. Even if you don't tell me, I'll post the link, and if you want to come. That's fine. All right. Yeah, they're lovely, Tamale. They really are. They're lovely kids. They really are. All right. And you might know some of them. I don't know. Anyway, so these are display formula. So now I want to do some structural formula over here. Let's do these in green. Oh, let's do them in, it's lovely green. All right, so the first one is, we often say CH2, CH2. Okay, that's the structural formula. It just shows the structure, doesn't it? It's better than this one, isn't it? Better than the molecular formula. So sometimes the double bond is shown, sometimes it is not shown. I personally think you should show it because it stops confusion then. All right, what's propene? Well, propene is therefore going to be CH3, CH, double bond, CH2. But this one is sometimes shown as CH2, CH2, and you've got to imply that there's a double bond. You can tell there's a double bond there because there's not enough hydrogens, is there? But it's a bit nasty. They can be a bit mean on this. Propene is sometimes written like this. Okay, and you've got to just see, oh yeah, CH2 isn't right at the end, so there must be a double bond. I prefer this one, but they do the other ones as well. Let's have a look at butanene and butene. Butanene, this one, is going to be CH2. Oh, let me put the double one in because I think you should. CH2, CH, CH2, CH3. And obviously butene is going to be CH3, CH, CH, CH3. Now for butene, I've often seen this, CH3, CH, CH, CH3. And you've just got to imply that there's a double bond there. It's not easy at all sometimes, all right? But if you see CH, CH in the middle, you think, there's a double bond there. All right, let's have a look at this one. This last one, methyl propane, is going to be C, CH3, 2, CH2. Do we get the last one? Do you understand methyl propane? Can you see how that's a formula? Are we good? No, Janet's not good. All right, dear. Right, let's have a look at this. Okay, let me draw that for you. CH3, C, and there's a CH3 on this one. Then there's a double bond and CH2. Do you get that formula, Janet? Do you get the one I've just done? You do. Now, all I'm doing is, since both of these methyls, since this methyl and this methyl are on the same carbon, I'm going to say, well, there's CH3, there's 2 of them on that carbon, and then that carbon is bonded to a CH2. Are we good? Do you see that? Janet specifically. Yeah, you know what? These guys, all of you, these guys just take, well done, the other two. These guys, you've just got to get used to them, mate. That's why we're having these lessons. All right. You're not going to be perfect at organic chemistry after these silly lessons, I promise you. It's just to get you familiar with some of the things because it saves time, eh? It really does save time. All right. Now I'm going back to the top and now I'm going to do the skeletal formula. Okay. Now these are the ones I like skeletal formulas. Students hate them, but I like them. I'm going to do these in what color? This white color. All right, ethene. We know it's simply that. That's the skeletal formula for ethene. It's silly, isn't it? Propene is 3 carbons long. 1, 2, 3, with a double bond. That's propane. Oopsie daisy. Butanene is going to be this. You put your pen down. 1, 2, 3. Oops. 1, 2, 3, 4. And the double bond is between 1 and 2. Oh, that's pretty ugly. But butene is 1, 2, 3, 4. And the double bond is there. Yeah. And let's lastly do methylpropane. Methylpropane is 3 long. So it's 1, 2, 3. There's a double bond there, like propane. And then there's a methyl coming off. So do you all see that, the skeletal formula? Are we good with the skeletal formula? Yeah? Yeah, Janet's good. Now, Janet, interestingly, and Taman is good. Otata, I presume you're good. Right, well done. Now, Janet, can you see, remember you were worried about where these two CH3s come from? Okay, and there's one there and one there. Okay, Taman, don't worry, I'll do one. All right, there's one there and one there. But can you see, Janet, that these are the two methyls? Yeah. So if you draw the skeletal formula, it often explains the condensed formula. Does that make sense, Janet? Particularly, Janet. Yeah, it's nice, isn't it? But again, we're not going to be great at chemistry after this. All we can do is get familiar with some of these things. Honestly, that's all we can do. All right. So there you go. Now, what was I going to do? Oh, yeah, Tamani wants one example. So let's do a long one, eh? Let's do pent 3. Oh, does pent 3ene exist? All right, let's see if it exists first. 1, 2, 3, 4, 5. Have a look at this. And this one's number 3. Anyone want to tell me, does pent 3ene exist? Well, it does exist, but is that right? Have I done anything wrong? I've done something wrong. Did anyone see what I've done wrong? Don't forget IDK. Why? Yeah. Why though, Tavani? Why isn't pent 3ene correct? Janet doesn't know. Janet, you do know. Yeah, well done, Tavani. It's pent 2ene, isn't it? Yeah. No, the double. I put the pent 2ene. You can't get pent 3ene, everyone. Can you see that? You can't get pent 3ene because if it was pent 3ene, it would be pent 2ene. It's nearer the other side now, isn't it? Yeah, and we've got to start numbering to give us the lowest number. So you literally can't get pent 3ene because if you get pent 3ene, well, if you look at it the other way, it's pent 2ene. So this guy's called pent 2ene. So well done, Tamani. Correct. Right, I'm going to make it more complicated. And now I'm going to put a methyl on this side of the double bond. Okay, just to make it more complicated. Okay, and now it is, well, there's a methyl on my pent-2ene now, isn't there? Methyl, and where is the methyl? The number what? Anyone see? I'm not going to wait for you because I think you can see. The methyl is at number 2. So this is 2-methyl pent-2ene. Okay, are we happy with that name, where that name comes from? 2-methyl pent-2ene. Are we good? Yeah, Timon is good. Everyone else is good. Excellent stuff. Right, well done. Now, what am I going to do? First of all, I'm going to do the condensed formula. Let me do the condensed formula. The condensed formula don't forget this first one is called a displayed. This is a displayed formula. All right, and now I'm going to do a condensed formula. both of these, I hope you understand this, both of these are types of structural formula. They're both structural, but they're different, but they're both structural. What isn't structural is C6H12. That's molecular. That's a molecular formula, and we don't like those because they're ambiguous. Okay, so let's do the condensed. Well, the condensed for this guy is going to be a nice different color. CH3 for this, CH2 for this, CH for this, double bond for the double bond, C, CH3 twice. First of all, before I do the skeletal, do we all see that? Do we all see that how I got the condensed formula? Are we good there? Again, it's just a matter of getting used to this stuff. Well done, everyone. Good stuff. All right, now let's do the skeletal. Right, how many is in the main chain? There's 5 carbon atoms. So when I put my pen on the paper, I've got to say 1 and then count. 1, 2, 3, 4, 5. So, oh, bum. Look at that. The pen does that sometimes. It's annoying. Okay, so at the moment, that's the skeletal formula of what? What is that, the skeletal formula? What is this guy? At the moment, the skeletal formula of what? The name of that compound. Yes, it's pentane. Well done. Excellent stuff. Now, we've got to put a double bond at number 2. Well done, Janet, as well. Money. We've got to put a double bond in. The double bond is at number 2. It's not at number 1, it's number 2. So where is number 2? Well, this one's number 2. There's number 2. So I've got to put a double bond in there. So now it's pent-2-ene. Are we good there? Pent-2-ene? Everyone's happy with pent-2-ene? Excellent. And now I've got to put a methyl at number 2 as well. Well, this one's number 2. Let me put a methyl. There. Oh, that's a pretty ugly one, but there, that's a methyl. And that's the skeletal formula of 2-methyl-pent-2-ene. Okay, are we good? We're good, we're good, we're good. All right, I hope we're good. Are we all good? We're good, we're good? Yeah, I'm sure we're good. All right, now we're not going to do much chemistry at the moment, I'm afraid. We're going to do some isomery stuff, okay? So I want to look at this compound here, okay? I want to look, and maybe you've heard of this, but maybe you haven't, because I don't think you've done much organic. The bad thing about the IB, my honest opinion, is that you don't do any organic in the first year, like last year. All right, IB1 or whatever you want to call it. I think in future years, if I have anything to do with it anyway, you'll do some organic in IB1 because it's crazy a whole year without organic. I think it's bad for you. All right, so that's beside the point. We can't change the past, can we? So let's have a look at this guy. Let's have a look at bute-2-ene. We're going to look at bute-2-ene a little bit more in detail. So what's bute-2-ene? Well, first of all, we know it's C4H8. By the way, the general formula, I didn't mention this, but the general formula of alkenes is CnH2n, isn't it? Okay, that's the general formula of alkenes. So we should all know that. I'm sure we all doing that from last year or 2 years ago, whatever. So let's draw bute-2-ene. All right. Well, first of all, I'm going to draw the condensed formula. CH3, CH, CH, CH3. And now I'm going to do the displayed formula, which we've done already, like this. Okay. Now, this lesson might confuse you a little bit. Okay, so this is the displayed formula of bute-2-ene, but I'm going to draw another displayed formula. Have a look at this. Now, what have I done there? Now, ladies and gentlemen, are these two the same? Excuse me. Are they the same? All right. Yeah, I'd like to think they're the same. Now, I'm going to mess you around here because there's no way you should know this, but they're not the same. Okay. Now, before we can look at this, we're going to have to go back a tiny bit and look at something here. All right. I'm sure you're all confused a little bit. Let's have a look at this. CH3. Where are we here? This one. What am I going to do? I'm going to put a Cl at the bottom and an H there. And I'm going to draw exactly the same thing over here. Well, not exactly the same. And I'm going to put an H there. And I'm going to put a Cl here. Now, are these two things the same at the bottom? Do we know? Are those two the same? Not the top two, the bottom two. Are they the same? Are they the same thing? Yeah, everyone's crying here. Yeah, people don't like that. Oh, you know what? This is a topic we should do in class because this is quite hard to understand. Okay, but don't worry about it. We'll figure it out. Okay, let's have a look at the bottom one first of all. Let me draw this nicer. Okay. All right, now I'm going to draw it like this: carbon. And I'm going to draw the stereochemistry. In other words, I'm going to draw the kind of what it looks like, as it were. Okay, do you remember this? It's tetrahedral around each carbon, isn't it? So there, and there, and there. Would we agree? Well, there's a hydrogen here. Are you happy with that representation of chloroethane? This is chloro. Yeah, that's good. This is chloroethane, isn't it? All right. Now, I've just drawn it as it really looks. We draw this type of thing, all right angles. This is just for convenience, isn't it? All right. It's not flat, is it? It's not all 90 degrees. It's more like this with internal bond angles of 109.5. Okay, so there you go. And now I'm going to draw it again over here. I'm going to draw the other one. Now I'm going to be asking about some bond stuff here, guys, eh? So I wonder if you know some of this. I'm sure you do. All right, what goes up there? Yeah, so do that. And then that one goes down there. Okay. Now, these, believe it or not, both of these representations show the same thing. This is the same thing. Why is this the same as this? Does anyone know why it is? Why do we say they're the same thing? Bit tricky, but there you go. Do you know why they're the same thing? Anyone? This is going to be, if you don't know, don't forget IDK is fine, or a down thumb. Either is good. Yeah, we don't know why they're the same. That's okay. Now, having a look at that, if I gave you the model on the left and the model on the right, how would you make them the same? What would you do to the model on the left to make it the model on the right? What would you do? Imagine I gave you, well, flip it. Yeah, you would flip it, wouldn't you? Yeah, you could flip it. Or, yeah, you're quite right. You could flip it. And it would be the same, wouldn't it? Yeah, if we flip it. Or what you could do is this. You could rotate this group and rotate it like that. Okay? And then this group here would rotate up. All right, and that would become that. And that's what happens in chemistry. This bond here in the middle, and this is what I'm going to ask you about your chemistry. This is what we call a sigma bond. Okay, and a sigma bond is one of the p orbitals on one carbon, like that, there's a carbon, and one of the p orbitals on the other carbon overlap, and it is end-on overlap. Okay, are we good with that? And what we get is we get the carbon, and then we get a bond in the middle, and then we get another carbon. Okay, and it's end-on overlap. Right, guys, I'm gonna stop the video, stop this for now. Okay, you'll see why in a minute, I'll tell you why.